again welcome you all to my YouTube channel, the SCADA Insider. So in today's tutorial, we are going to dive into the most widely used communication protocol in substation automation, that is DNP3, and also we call it as a distributed network protocol. Currently, the version which we are using is version 3.0. So what is DNP3? So it is a very robust and we can say as a event-based protocol designed for SCADA systems where the application may be into the electrical substations, it may be into water management systems, oil and gas, and many more. So why this kind of application? Sometimes the controllers like RTUs, which are located at very long distances, they might communicate over cellular SIM cards, or it might be over any kind of wireless communication. In that case, there is a chance of loss of data, like we can say a critical data. In that case, DNP 3.0 is very much useful as it supports the buffering functionality. Okay. So as I said here, it is designed for mostly a poor communication links. Then it handles remote telemetry like from RTUs, PLCs, meters, and intelligent electronic devices designated for over poor quality of links. Then it supports the timestamp based event. So what is timestamp based event is like in Modbus, whenever there is any kind of communication loss happening, so we lost the data for that particular duration. But in DNP3, we have a function like buffering is available where we can, in case of any kind of communication loss, the data is being stored at the controller itself, like at the RTU in itself, and we can configure the number of points or data, how much we can buffer into that RTU, and all those data is buffer along with the timestamp events. So the value is available with timestamp. So whenever there is any kind of communication loss and the communication regains, the values will be available at SCADA along with the timestamp. Okay, then there is secure control of commands. So we have different command function codes available into DNP3. Like we have write, select, operate, then select, direct operate. So these are all different kind of command functions in DNP3. What is the use of this command is basically suppose there is any critical application like circuit breaker where there are two types of commands available. One is direct operate. Once operator click on the command will directly go to the breaker and breaker will turn on or turn off. But we can also select as select before operate, right? Where first we need to give a select command. Breaker will be selected. This is a kind of confirmation at the operator level that we are going to open the or we are going to open the breaker or close the breaker, and then we give the operate command. So this is kind of second verification happening. So this kind of functionalities are available in DNP3 protocol. Also, we will see this command function when we see the live demo with the test simulator. Okay, and event-based communication. As I mentioned, we are available with the timestamp. So there are different kind of categories or classes available in DNP3 where we can segregate the data. So the static data can be configured in class 0, the critical data can be configured in class 1, the analog values which are not so important can be configured in class 2. So there are also classes available in DNP3 and that can be configured into the RTU or the particular device which is having which is supporting the communication protocol DNP3. Right now, what we will do, we will simply go to the demonstration. So you will get a clear idea. I just give you the basic info of DNP3 protocol. You can just search on web and get more depth into the DNP3. Now, how to communicate WinCC OA SCADA with DNP3 protocol? So for this, I'm using a Triangle Microverse test harness, which I already showcased you for communication of IC104 for Modbus. Similarly, we will use the same test harness for DNP 3.0. What we need to do is basically we need to create a channel. So I will just create a channel. Now in this case, our test harness will act as a server. Okay, I'm creating this thing, and in channel I need to mention it as 127.0.0.1. The port number will be this one. Open. Okay. Now we need to configure SCADA. So for configuring SCADA, I will just start the SCADA project. Already I think it's running, but I will just check. Okay, I'm starting the SCADA project. Okay. Now as we have configured different drivers for different kind of simulation, now we need to configure DNP3 driver. How we can do this thing is we need to go to manager properties. We need to select the DNP 3.0 driver. Yeah, this one. And click on always. You need to give the manager number, which I've already mentioned you that it should not conflict. Click on OK button. The driver will be added here. As I have already added a driver, I will not add it again. Now go to the development environment. So this is the development environment. At first, as I have already mentioned you for different kind of devices, here also we need to create a DNP3 driver device. Go to DNP3 driver. I did some kind of testing earlier, so I'm using this one. I will create a new for you. Create, suppose test device. We'll give name as test device. In this case, you can give the actual name of your PLC, your RT or any device which you are going to communicate. I'm giving the name as test device. Why it is giving? Okay, device. Data point name is already used. Why? Okay, I'm giving the name as area 1. In this case, host name I will give as 127.0.0.1. Then port number, which we have in this test harness. In test harness, we can see the port number as what is the port number? By default in DNP3, the port number is around 20,000. I will configure the same here, 20,000. Okay. Now, the major thing which we need to configure is every device, every sorry, I can say server is having a source address and destination address. So here the source address is 4, okay, and destination is 3. So we will be configuring this source address in this link address. So here LA means as a link address. I'm configuring this and click on apply button, apply, right? And I will make this as unsolicited response so that whenever any kind of changes happen into the system, it will immediately be reflected here. Apply and OK. Okay, so I've did this thing. Now what I will do, I will just go to the area. So I'm going to area and we will just do configuration related to the tag which we already did for Modbus and OPCUS. Same data point I will be use data point type I will use. Here now I will use as CB5. Okay, and in this one again, first we will configure for binary value. We need to go to the periphery address. Then periphery address we need to select it as a DNP3, make it as configure. Now it will ask which device you need to select. Currently we have configured area 1 as the device, so I will select area 1. Now the direction will be input and we will first select polling mode, then I will also explain what is unsolicited. In this case I will just select as 1 second. Function code, as we are taking it as input, we will not see this thing. Then in binary group I will select as binary input, variation I will select as 1. Okay, then index let it be 0 and driver number, which is very much important, we will select it as 2. Click on apply. Okay, I've just selected apply. Something I just forgot to make it active. Click on apply button. I clicked on apply button and just we will check why it's not getting communicated. If there is any error being fetched in the log. Mhm. I don't see any error. Then why we are not getting value? Value is not available because I already had a device which is already connected to this one, and in this one area not connected. Why so? This driver it's getting. Oh, I think so. There are two connections. That's why we are not able to communicate. Okay, apply, apply. Yeah, now you can see it is getting connected. Already there was one connection established, so it was not getting connected with this one. So I just deleted the existing connection and new connection is given to this device. Okay. Now here we can see the state is connected. I will just go to the on, and currently the value is coming as false. We'll go to the simulator and go to the data window. In data window, now see in DNP 3.0 we have this kind of what I can say is yeah, groups available. Sorry. So there are different kind of groups in like we have seen in IEC 104. There are different object types available. Here we have different kind of groups available. So for getting the binary values from simulator, we need to configure the group as binary input. Variations, we can see there are different kind of variations. So what are those variations are? Those are different kind of I can say as mm, suppose there is an analog value coming. Sometimes the analog value may be 16-bit, sometimes the analog value may be 32-bit. Okay, so there are different variations available here. According to that variation, the value will be coming into this particular data, right? So for binary input, if I select variation as 1 and index at 0, we'll just check whether the value is getting updated or not. I will change the value. Now the number which we are checking is address is 0. Similarly, we have configured the same address here as 0, and we have maintained the receive mode as 0. Go to original and change the value. I will toggle it. Yeah, see the value is being getting changed. Okay. I will again make it as 0 or 0. The value is getting 0. Now, in this case, mostly we are using a receive mode as unsolicited because polling is same like Modbus. In this case, whenever data is being updated at the controller level, the SCADA master will always request the data from the controller, and the controller will send the response in. Okay, but what application we have checked previously that DNP3 supports buffering, and in buffering, whenever there is any kind of communication loss happening, that should be stored at RTU level, and whenever the communication is regained, the buffer data should be sent automatically to the SCADA, that is our master. In that case, we say that kind of communication as unsolicited. What it means is whenever there is any kind of data change happening here, it will be directly sent to the SCADA system. There should be no polling available. Like SCADA will not send any kind of request, but the data will be sent from the controller to the SCADA upon change into the controller. Whenever there is change happening into the data, it will be passed to the SCADA system, and it will be sent according to the class available. So I already mentioned class 0, class 1, class 2. Depending upon that class, the data will be prioritized and the data will be sent to the SCADA system, right? Now I've just shown you the example of binary. We will also see an example for we can say for analog values. Okay, so I will just configure one tag periphery address. We will go here, select it as a DNP3, configure input. Instead of binary, now I will select as analog input. So our group will be analog input. Transformation, there is no change happening here. Instead of polling, now see I'm using unsolicited, address active. Then variation, I will select it as one only. Okay, apply, and driver number, yeah, mention driver number, else our device will not communicate. Go to this one. I will go to analog input. Still, we are not getting communicated. Why so? Area active. Okay, the data has not changed yet, so it is not communicating. I will just change the data. Suppose I make it as 1 2 accept. It is not changing. We'll just check whether the unsolicited mode is yeah, see. So whenever the data is being changed here in the simulator, immediately it is reflecting it into the SCADA. And the mode which we have used is unsolicited mode, right? We are not using polling because in polling we need to give the poll time and poll duration, apply. It will be continuously polling. It will be continuously polling. We don't unnecessarily like we don't want to necessarily give load on the particular network, right? So whenever there is any data change happening here, then only we need to get data. So instead of the polling, I will use this particular unsolicited mode. Apply original. Now I will make change of the values to any other value. Suppose I make it to 45 and make it as accept. Uh, so this will be detected here. Yeah, okay, see the value has been changed into this thing like the SCADA. You have seen this thing. Okay. So let me summarize everything. So what we have seen how what the DNP3 driver is, what are the function codes, what are the groups and variations available. Okay. Also we have seen the live demo while communicating binary and analog values. Okay. If you found this helpful, then please like, subscribe my YouTube channel, and for any kind of question, and please drop your comments into this comment section. Okay. So in next tutorial, we will see the designing of SCADA screens and WinCC UI. Have a nice day.